All right. Hi, everyone. Good evening, good afternoon, good morning. I hope all are doing good. So today it is going to be our next session on in the series of developing solutions for Microsoft Azure, that is certification AZ-204. So we have started this thing in April, and April 25th we started the first session, and so far we have completed two sessions. And here are the links for our group. We will be posting those links in the chat as well. And these are the few people who are behind the scene working actively in all the sessions. So today agenda is AZ-204, developing Azure. uh, Arun, we are ahead of the slides, right? I mean, we have to go back. Okay, so today agenda is
You
Arun. Can
want
you,
me to go back?
yeah, please, the title slide, the agenda
Okay.
slide. Okay, so today the next one. Yeah. Yep. So develop for Azure Storage. This is the module that we are going to cover, and in this module, before we go into the you know the details, what exactly the topic we are going to cover, we will just take few moments to kind of introduce our team, who are the people who are working for this session. Arun, can we go for the next slide? All right, so these are the people who are working, and you may, if you have attended our session in past, or if you are group, part of our group, then you might know some of them. So Vipin Jha is a Microsoft certified trainer and consultant. He has been working behind the scene to prepare the content for various series that we have done. We have done AZ-104, we have done AZ-900, we have done AZ-400, and now we are doing AZ-204. So Vipin has been one of the backbone behind the scene. Ram Murthy is one of our team member who is also actively helping us, all preparing all the content, and he has taken few sessions in, past series like AZ-900 and AZ-104. Myself, Ashish Raj, I'm co-founder of AzureTalk and Azure Easy technical group that we are, that is hosting this session. I am Microsoft certified trainer, I'm Microsoft certified professional and DevOps architect. I'm based out of Bangalore. Then we have Free, who is based out of Canada, working with Microsoft. He is also helping us with all the things which could help us. I mean, which is helping us to prepare all the content that we are able to, present in front of you. Sanjeev is our next speaker for today's session, and he is a senior software engineer and Microsoft certified professional. He is, taking, all the sessions of AZ-204 lab, and he has also taken few sessions in AZ-400 DevOps series that we did previously. Nitanshu is part of our team. He is also helping us with all the content preparation, coordinating all the speakers and all. And now he is also, he has also done sessions during AZ-104 and 400, that is DevOps series. Kritika, she is also one of the active participant of our sessions, and she has been contributing a lot in AZ-104, and she is still, she is also helping us with all the content that we are preparing in this series, and for all the upcoming series. Arun, you will soon hear about him. He's going to take the first part of our session. He has been, active contributor to the community, and he is a Microsoft certified trainer and cloud architect, and based out of Delhi. So this is the team behind the scene. There are a few more people. We are going to update the slides very soon. So those are the people who are working. So today's speaker. So Sanjeev is going to take the second part, and then we have Arun, who is going to take the theory part of the session. So I think the order, we were not able to update the order. So yeah, Arun will be taking the first part, and then Sanjeev will be taking the second part. So that's how it's going to be. Now, just this final slide, and after that, we are coming to the main agenda. This is the slide that we want to tell. After the session, we will be having a quiz. Now, when you participate in the quiz, you become eligible for winning the Azure exam voucher. We are going to give free Azure exam voucher for selected 6. The winners will be announced in the next session. Today, we are going to announce the winner of the previous session. This is the format that we have been following. So today, if you participate, you might be, your name might be get selected in the next session in the lottery system, and one selected participant will be getting a free print copy book, that is demystifying Azure DevOps Services, that is written by me, Ashish. And just one condition there, along with participating in the quiz, you must be registered on the Eventbrite. We have posted the link where you can register. Go ahead and register. You will be getting two things. One, you will be eligible for the quiz, giveaway. Plus, you will be getting all the notification for the future sessions. This is all we have. This is what we have. We have been doing for last 3 series: AZ-104, AZ-900, AZ-400, and now it is AZ-204. So it is like 4 series in the sequence. Now I'm going to introduce you to our speaker, who is Arun, and Arun will just take forward from here. He will just explain you the slide that we have. Arun, please go ahead. Thank you.
Thank you, Ashish. Hey, everyone. Uh, well, these slides you must have seen a couple of times as you are with us in AZ-204 series. So by completing this certification path, will once we clear the exam, of course, only then we'll get this Microsoft Certified Azure Developer Associate badge. And this is the exam. And if we talk about the skills measured in this certification, so it's a developing certification path. So you gotta develop Azure Compute Solution, Azure Storage Solution, Azure Security, monitor, troubleshoot, and optimize Azure solutions, and connect to and consume Azure services and third-party services. These are the major topics that you need to cover for this certification. And if you see, maximum weightage is for compute solutions, and then it falls to the security, and rest all three almost same 15 to 20%. So today we have Azure Storage Solution. Okay, and in this we have the agenda: develop solutions that use Cosmos DB storage, and solution for Blob Storage. So before we start digging it further, I must appreciate the enthusiasm of all the people sparing time to join this training, that too on Sunday. And I'm sure at the end of this session, you must be learning something. You will have something new in your pocket to talk about. And this session is going to be really intense, as topic, especially the Cosmos, is very tricky and wide as well. So we're going to do a lot of exploration and too many things to understand. So this time it's me who is doing the theory part, and you all know my understanding of theory, it's kind of boring, right? But I'll try to make sure that we would have some fun by adding a lot of examples that you can relate to, so that it would not become boring. Okay. So let's learn something new today together. And as per agenda, let's start the Cosmos DB. So don't you think it's an interesting name? Well, I do. And let me tell you, not only name, its entire functionality is very interesting. So let us try to learn Cosmos with a simple trick: what, why, or how. So what it is, why we need that, and how can we implement it, or how can it help us? This is very simple way, very simple questioning way of learning anything. And trust me, it's highly effective. So Cosmos. Cosmos is a PaaS service, platform as a service, or managed DB as a service, or to be specific, it's a cloud-based NoSQL database as a service. And Microsoft describes it as a globally distributed multi-model DB service for mission critical applications. So what we understood with this definition of Microsoft, let's break it. Well, Cosmos DB is a fully managed service and have a kind of serverless architecture. And it is an example of database as a service where you do not have to set up the database server or manage them. Instead, you will just get an endpoint for your application to utilize. So you do not need to think about the memory, CPU, hardware provisioning, OS optimization, updates, patches, SSL certificates, etc. Uh, as per any typical PaaS service, all the operational overhead of managing database is gone, which will save you a lot of time and efforts, which could be utilized on the primary task like application development, which is also protected by amazing numbers. I mean, SLA for uptime, which is 5 nines. Yes, you heard it correct. It is 99.999% of uptime. Now we know what it is, and it's time to understand why we need it or how can Cosmos DB help us. Well, few things we already understood as benefits of PaaS service, but we need something more. So let's dig it further. So let's suppose you do not have such a wonderful service like Cosmos DB, then what you're going to do? And your application is globally distributed. So of course, you're going to create a globally distributed database with the resources available, right? But let me point this to you first. It is very difficult to manage such a huge infrastructure in global distributed application. Also, maintaining the uptime like 99.999 is very expensive and requires a lot of finance as well, along with the maintenance. Another pain point is to keep a sync between application schema and database schema, and of course, indexes. But the Cosmos DB, you get all that infrastructure with minimum management, and you do not have to deal with schema or index management as well. This database engine is fully schema agnostic, and no schema and index management is required. You also don't have to worry about the application downtime while migrating schemas. Guess what? Cosmos DB automatically indexes all the data. Well, looking all these features I did mention at the beginning as a kind of serverless architecture, right? So it is more like a SaaS service or close to SaaS service, right? So with these questions, what, why, or how we familiarize ourselves with the wonderful service. So let's move ahead and see the other features that we should be aware of as per the certification path. So I'm sure a lot seems familiar because we already covered while trying to understand the service, right? Like managed DB. We understood that perfectly well. It's a PaaS service, globally distributed. Now, let's take a minute and understand this. Cosmos DB doesn't only replicate data set to inside the data center, but also gives you ability to replicate to multiple data center, that too in a different regions, and distribute your data globally. All you have to do is click. If you are familiar with the Azure SQL geo replication, it is just like the similar functionality, not exactly, but yes, similar functionality where you have that global map in front of you. You need to choose the region that you want to replicate to and click on that. It's that simple. And that is the reason it is also called turnkey global distribution. Just turning a key using your mouse, that simple. If you want to relate it as I said, you can relate it with the Azure SQL database geo-replication so that you would have a picture in your mind what globally distributed here, but we need to add one more thing. We can also write. It wasn't there in the Azure SQL database, but turnkey global distribution, you can relate it. All right, let's hit the multi-model and multi-language, okay? So that simply means Cosmos support almost all kind of NoSQL databases available. Let me explain. We got four kinds of NoSQL databases, right? Like a key value, document DB, graph, or column DB. Now, if you have a key value database, Cosmos can handle it. If it's document, Cosmos can handle it. If it's graph or column-based database, guess what? Cosmos can handle it. So no matter what kind of database you have, I mean, NoSQL database you have, Cosmos can handle it. Now, just wanted to add here, this was one of the reason Microsoft Azure changes the name of the database from Document DB to Cosmos DB. Yes, you heard it right. This service used to be Document DB, but because of such wide functionality and the features, the name changed to Cosmos DB. Since it's no longer limited to storing JSON documents only, and that is why it's Cosmos DB now. So along with that, Microsoft Azure also released SDKs for multiple programming languages. So now you have Java, .NET, Python, JavaScript, or many other languages uh, supported by Cosmos DB. Now, high availability, HA, reliable, scalable, and secure. You can easily compare these features with PaaS services or any of the PaaS services provided by Microsoft. We already discussed about the 5 nines availability of Cosmos DB. I'm pretty sure you're not going to forget that because I've mentioned a couple of times. So Cosmos DB also certified with wide array of compliance standards. Cosmos DB is encrypted at rest and in motion, and also provide row level authorization and many of the security features like network firewall, etc. So Cosmos DB also provide unlimited scale for both storage and throughput. So there is a concept of horizontal partitioning in Cosmos DB. Horizontal partitioning allow Cosmos DB to scale limitlessly. We will understand that part when we'll be understanding the structure or the partitioning key or the partitioning. Okay. Similarly, you can tune the performance of your database by provisioning throughput as needed, and Cosmos DB automatically allocate the necessary resource behind the scenes to ensure that the performance level get delivered. So Cosmos DB also have a flexible pricing model. Since we started talking about the storage and throughput, so I have to mention here, though it is not there in the slide, but don't worry, this is something that hit my head right now. So it is like Cosmos DB price separately for the storage and for throughput. And now we also have the serverless Cosmos DB, just like in Azure SQL database. If you have worked with the Azure SQL database, we have like DTU as a unit and vCore as a unit. When we choose the vCore and DTU, there is an option like provisioning or serverless. Same kind of option we do have now in Cosmos. You can opt for the serverless Cosmos DB as well. Now, 5 level of consistency. This is one of the great feature which is also very important as per the exam perspective or interview perspective. And we do have multiple slides to explore it later. So let's dig a little deeper on these features which make this service so amazing that Microsoft calls it Cosmos. Let's start with the multi-model. Okay, multi-model. We did talk about multi-model at the beginning, like there are like 4 NoSQL databases. So let's understand it further. So the types of NoSQL DB first, as we mentioned, there are generally 4 types of NoSQL DBs: key value, document, columnar, and graph. Cosmos DB have different APIs to support or access all these 4 kind of databases. For example, Cosmos DB has table API to support key value, and Cassandra API to support column-based database, Gremlin API to support graph, and Mongo and SQL for document DB. SQL, JSON, Mongo, Basin. Okay, so that means no matter what kind of NoSQL database you want, you can design it in the Cosmos DB. And also, if you have existing NoSQL database in your on-premises, you can easily migrate that to Cosmos DB, and Cosmos DB has API to support it. Now, if you are wondering how to choose the correct API, or it seems confusing, let me make it very simple to you. If you have your existing application in Mongo, Cassandra, Table, or Gremlin, you can choose the respective APIs. It's as simple as that. Okay. Now, if your data has a relationship or designed in graph model, or you are planning to design in graph model, then you should consider Gremlin API. And for everything else, go with the default, that is SQL API. So now we understood the different APIs that Cosmos supports for different DBs, and it's time to explore global distribution. All right, so today's applications are required to be highly responsive and always online. To achieve low latency and high availability, instances of these applications need to be deployed in data centers that are close to their users. These applications are typically deployed in multiple data centers. Globally distributed applications need a globally distributed database that can transparently replicate the data anywhere in the world to enable the application to operate on a copy of the data that's close to its user. Well, this architecture of globally distributed application, as you can see in the backend, Cosmos DB is replicating to the other regions. So if we go through this architecture, let me change the pointer if it could help us. All right, so we have these devices with the help of which we are browsing through internet. Our request is hitting the traffic manager, and it is diverting the request near to the user. It could be West US, it could be North Europe, it could be Southeast. And all this is a single application. So what is most important? These databases which are catering these application in West US, Cosmos DB here in North Europe, or any DB here in Southeast. So these should be in sync. That's how the global distribution application works. So Azure Cosmos DB is globally distributed database that allows not only read like Azure SQL, not only read, but also write data from the local replicas of your database. Azure Cosmos DB transparently replicating the data to the regions associated with the Cosmos account. Okay, so to lower the latency, we place the data close to where the users are. For example, if we have our users, all the users in West US, we do not want to spend money and create infrastructure in Southeast Asia, because our most of the user base in West US. But in this particular globally distributed application, we have a global user base. That's why these are in the different regions. So to reduce the latency, we try to place our servers near to the users. So there are some key benefits of global distribution, like unlimited elastic read and write, scalability, availability, and guarantee to serve reads and writes in less than 10 milliseconds. we are talking about the Cosmos here, okay? Because of these benefits, we can build global active applications, highly responsive applications, highly available applications. We're all talking about global level, not the in particular region, okay? Now, with global distribution, it's time to explore the subset of this topic, which is multi-master. Now, when you create the database, Cosmos DB in Azure portal, and it will ask you to create the account first, then the database and container. We'll talk about that later. But here in the multi-master, we need to check. There is an option under settings like replicate data globally. And this is the turnkey. Just select the region and enable it. But this is where the magic happens. You got to enable the multi-region right. Of course, you got to pay double because the double efforts are there. You know, entire infrastructure is getting created there. A lot of efforts Cosmos is gonna do for you. So that's a different thing. For now, we need to understand the multi-master, right? So let me try explain it further because this one of the critical feature of Cosmos, an important topic as per the certification as well. So let's suppose, let me get this point changed to the pen. Let's suppose, okay, there is your primary region, okay, and you got 3 read regions right here. One part of this global map and the other part of the global map. You can say anything like one of this is West US or Japan or East US or maybe Europe or India. It doesn't matter. What matters is they are different regions, and these 3 regions are read, and this is the read and write both, the primary region. Okay, so let's suppose West US is the, let me do this so that it would be highlighted. Yeah, let's suppose West US is the primary region for read and write, and you enable 3 more read region. Now your data has been replicated to these 3 regions. Let's call them East US, Japan, or Europe as read. Now the point is, let's say we have user in Japan. And if user trying to access the data, it will be very quick because data is available locally for read purpose only. Remember, it's a read. So replication happening on these regions, but only for the read purpose. But what about if that user tries to write some data? Well, this center is a read only. We know that. So for the write, we only have one center, that is West US. Now, if the user in Japan tries to execute the write statement, it will go to the West US first, to the primary region, update the data, and that data updated will replicate back to the Japan center. And this will definitely add some latency. So read is going to be fast, no doubt, but the write is going to be slow because the write statement has a strict travel across the globe. Not only once, but twice while coming back to replicate data to the read center that was like Japan. Now, Cosmos DB has a solution for this problem, and that is called multi-region writes. So what you are gonna do, you will enable this feature here and make these regions write as well. So once you enable the multi-region, all the read regions will become write. And now all 4 centers are exactly same for the user. Read and write both can be done from any of these centers. Now you have a user in Japan and that user execute the write statement. That write statement can be executed right here in the data center in Japan, and data will replicate to any of the data center later. Okay, or it can be configured the way you want it. Okay, now all centers can read and write, and this is what is multi-region write is, or multi-master property of Cosmos DB. Okay, now you must be wondering, it sounds interesting, but people would be updating all the time and everywhere. the users from these region would be updating here, users from this region will be updating here. All the regions are getting updated and data is flowing everywhere. So what if conflict arises? And you are not wrong, of course. There could be there could be a region that conflict arises, and we have a feature, or we can say a solution for such scenarios that can help us fix those conflict issues. Okay. Now, and Cosmos called is conflict resolution property that we can find under mode that might be shown in the demo part as well. So which can help you design logics. Logics like what? Logics like all the time, whatever is the last write, that would be the final write. We call it last write wins. So whosoever updated last will win, because there is always a timestamp on the update or the record update or changes or modification in the database. So there may be difference of merely milliseconds, but it would be, as every document in Cosmos have timestamp. Now, another logic. This one is the first logic. We got three logics here, three ways we can fix this conflict resolution issue. The very first last write wins. The another one is merge procedure, which requires stored procedure, where we can define a logic. Let's take an example of e-commerce website where you can see the price of the product is keep on changing. You might have seen with the different such e-commerce applications available, right? So we can put the logic like higher price always wins. It doesn't matter who is updating, where is updating, whichever price is higher, we can create such a logic that the higher price will win. Now there is a third option as well, which is simple merge without stored procedure. And in this logic, records will go in some kind of folder or like a bucket and later can be sorted manually. So I hope multi-master is all clear now. However, it also raises the question of consistency. For example, if you have data in West US and another in different region, let's say UK region, now it usually replicate quickly. But for example, let's say, or let's take the same example. Let's say data from this region to this region takes 10 seconds to replicate, just for the example. Now you have updated, let's suppose at 8 p.m. here, and somebody is reading here at 8 p.m. plus 2 seconds. Now there are two situations. Do you want user to read old data? Or you want user to wait for 8 more seconds to get the latest record, which is coming from here to here? In this example, we have a situation of consistency and availability. If you want latest data, then this will fall in consistency. And if you don't want to wait, then it will fall under availability. Like user can read whatever data is available, may be old, because new isn't updated yet. There is still a replication going on. So data availability means user should not wait for every request to be updated. And consistency is every request should be updated, and we have to choose as per the need of the application and fulfill these kind of scenarios where Cosmos DB provides 5 level of consistency. So these are the trade-offs between availability, consistency. Which one you want to choose? You're going to give the preference as per the need of your application, as per the requirement of your application. And Cosmos provides you 5 level of consistencies that you can choose from as per the need of your application. So these 5 level of consistencies are strong consistency. bounded staleness consistency, session consistent prefix, and eventual. These 5 consistencies that we need to go through now, and you will find these 5 consistencies in the Azure portal as well, along with the magical node option that I'll show you in the next slide, when we'll try to understand each of these consistency levels in little detail so that we know when to choose which one. And if there would be any question regarding the consistency in our exam or in the interview, we can easily answer those questions, right? All right, so let me move to the another slide. Strong consistency. Now keep looking on the screen that I'm sharing. You'll see everything is updated on the same time, at the same time. You see here we have West US, West US 2, East US, Australia East. That's like across the globe. But if somebody's data writing here, on all the different regions, it's updating at the same time. Why? Because it's a strong consistency. It's maintaining the consistency. It will allow you to read the latest data. Doesn't matter if you're reading it from Australia East or East US, you are reading the same data. Follow the color coding. Red, 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 blue, come on, blue, blue, blue. It's a representation of the consistency through these musical notes. I call it magical notes, but it doesn't matter what we call, we need to understand the concept. So the data is synchronously replicated to all the replicas in real time here. The mode of consistency is useful for application that cannot tolerate any data loss in case of downtime. Hence, the recovery point objective is 0. Strong consistency offers linearizability. What is the meaning of this word? You'll find what I was saying, red, 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 and blue, blue, blue. This means the order of the operation is preserved. It's not like red is updating here, but this guy is reading blue. So the order is preserved and the reads are guaranteed to return the most recent version of the item in the database. That is strong consistency. However, with strong consistency, there is a substantial increase in the latency because the people who was reading from East Australia East need to wait until the data is replicated completely, because it's a strong consistency and this guy want to read the latest. For example, let's suppose this is a financial transaction, so he doesn't want to wait, right? He wanna read the latest. Maybe it's a share market thing, because for us, for milliseconds there are billions of money on stake, right? So this is what the strong consistency is. And now let's move ahead and check eventual consistency. Well, I pick eventual consistency, though it's not in the same order in the Azure portal. Eventual is the last and strong is the first. Why? Because it's easy to understand, because this is just opposite to the strong. We have eventual consistency where there is no guarantee you can read data, like updated data, but you will have the availability of the data. For example, if you follow the nodes, everything would be clear. This is the primary region. You can say like this is the region where it's not the primary. Like here, it's the right region as per the example. Read, read, read. So let's make it read is happening in West US. And if you see the other regions, if somebody's trying to read something, he has something to read. He has the availability, but it's not the updated one. That's the eventual. But eventually, at the end of the day, or maybe at the end of this musical node, all the data would be replicated. All the regions would have the same data, but they would be eventual. But we need right now. Right now, we may or we may not have the updated data. So that is the eventual consistency. And this is the weakest consistency in the all 5. The first thing to consider in this model is that there is no guarantee on the order of the data as well. If you see black, but here it's green, and here blue, but a different node is coming here. So even there is no guarantee of order as well. Okay. So this is eventual consistency, and this model offers, it's not like everything is bad here, but this model offers high availability and low latency, along with the highest throughput of all. This model suits the application that does not require any ordering guarantee. The best usage of this type of model would be the like count of likes, tweets. Like it doesn't matter at the end of the day, it's the social media thing, right? So there is no lives on the stake, there is no finance on the stake. So you can, because this is also not that expensive, so you can opt for eventual consistency for that kind of application where you can wait until the latest data is coming to your data center. You know what I mean? So that is eventual consistency, and to remember what it is, it's just the opposite of the strong consistency, and it's not all bad about eventual. You do have the high availability and low latency, and you can use this for such kind of applications. All right, let's move to the another one, which is consistent prefix consistency. Now, just follow the notes, and you will understand what it is. Red, 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 but here the data is not updated. Blue, 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 but data took some time to update here. So you're seeing the order is maintaining. You see, order is maintained here. The first one is red in all the, second one is blue in all the regions. Third one is purple in all the regions. But it's not updating at the same time like the strong consistency. All right. So it's not necessary that you will read the updated data in consistent prefix, but you will read in order for sure. Okay. So the replicas guarantees the consistency in order, not in the data, but in order of the data, order of the writes, let me to be specific. However, the data is not always current. This model ensures that the user never sees an out of order write, just like in eventual, we were getting a different, right? Red, red, red. In eventual, you were getting sometimes green, sometimes blue. The order was not maintained. So the point is that it is not necessary that the data you are reading is most updated, but it is certain that the data you are reading is in right sequence. Let's move ahead to session consistency. Well, this is the default consistency of Cosmos DB. When you create, this is what is always selected. And if you want a different one, you need to select it accordingly. Now, if you have to see this vertical here, West US, where the write is happening in session A, in session A, in session A, all the regions where the data is replicating in a same session, but Australia East in a session B. So you can see all the data is strongly consistent in session A. It doesn't matter in which region you're reading. But in Australia East, it's not, it's taking time because it's replicating. It's falling in a session B. So session means that within the session, you will see the most consistent data. But outside the session, it is only guaranteed that you will see the consistent prefixed data. What that mean? We discussed about the consistent prefix in the previous slide, where the order is maintained, consistency in order. So that's why I said in session B it is consistent prefixed, because the order is maintained, but it's taking time to replicate here. Okay. Now, in summary, session consistency provides strong consistency for the session, ensuring the data stays up to date for any active read-write session. The availability of data is relatively high with lower latency and higher throughput than the bounded staleness that we'll talk about in next slide. So the possible candidate for this kind of model could be typical e-commerce application, social media application, and other similar services with persistent user connections. So let's go to bounded staleness. Follow the notes for a few seconds and you would have your answer. What kind of consistency it is. If you are seeing these notes, you see invest US2 and read and write and read invest US2, it's strongly consistent. But in read, like East US and Australia East, it takes some time and then it is strongly consistent. Why? Because we manually decided like after 5 seconds it will start replicating to the other region. That's why. Or you can also say like after 10 reads, after 10 updates, it will start replicating. So you can decide that trigger. That's why it says staleness, bounded staleness, because you have decided that after 5 seconds it will start replicating to the different region and you can read it. So in this, where you have started, like in West US2, you are starting writing and you would have the strong consistency, but in the other regions, it will wait for some time that you decide and it will replicating and you would have the strong consistency even there as well. But after some time that you have decided. So in summary, the data is consistent beyond the user-defined time or operations threshold. The performance of bounded staleness is better than the strong consistency. However, the availability is still low due to inherent lag for the replication that we put it there. Okay. All right. So let me go to another slide and conclude this. Well, it was quite a discussion on consistency, and I'm sure there must be a confusion, but now you would have idea how it works. And I'm sure if you read about it or listen the recording of this session, you would be able to manage easily. So let's conclude this. And now this will help you understand placing the consistency level as per the need. So we have all these 5 consistency levels: strong, bounded staleness, session, consistent prefix, and eventual. And if we are going in this direction, the availability is getting increased, latency is getting lower, and higher throughput. That was the beauty of the eventual. In this direction, the consistency is getting better because this is the strong consistency. In all other levels there are some situation, right? In bounded, you're defining the time. In session, it was in the session only. In consistent prefix, it was maintaining the order. And eventual, there was no state consistency, though it was getting all the updates at the end of the day, but it was not consistent at all. So this is the conclusion, and this will help you to place this consistency level in your mind, and you can easily relate with all those magical notes that we have been through or gone through. So it's time to understand the structure of the Cosmos DB. Okay. Now this picture shows you how the structure is. Let me get the pen. Okay. Now at the top level of the Cosmos DB, we have to decide or create the account. Whenever you go in the Azure portal and you try to create the Cosmos DB, the first thing you create is the account. And now when you are creating the account at the top level, you have to decide then and there the kind of API you need: SQL, Mongo, table, what kind of, because inside the account you would have only single API working. If you need different kind of API, you got to create the another account. Okay. Now at the top level, it is always the database account, and afterwards you create data, and then inside the data you create container. Inside the container you create items. Now in Cosmos, within database, let me change this a little bit. Yeah, within database we create container. It's not like a single container. You can have more than one container. You can relate container as tables in your SQL server. If you're coming from the SQL background, it would be like a tables, and database is just like database. This would be the tables, and if you have to relate, the items could be the rows. Okay, just related as per the relation or the SQL server structure. So it makes a kind of hierarchy where top level is the account, then database, and then containers, and then finally items. Now here we interact with the container. Okay. Now, if you are following the SQL analogy, well, there is a small difference because you see all these things are connecting with the container, not with the database. We generally define stored procedure, user-defined functions or other objects at the database level in the SQL, but here we are defining it in the container. Okay. Now, as per API selected on account level, terminology gets little different for database, container, and items. Some call collection, some call table, graph. Similarly, for the items, they're different names, and we need to understand. If we choose a different API, these names gonna change. So we need to understand that as well. Okay, so let me go to another slide where I have compiled everything and put it here that will help us to understand easily. Now you see here, we got Cosmos entities downwards like database, container, and items that we were talking about here, database, containers, items. And here we have all those five APIs, SQL, Cassandra, Mongo, Gremlin, table. So whatever APIs you're choosing at the time of creation of your account, Cosmos account, these things would have a different name. If you're choosing the default one, SQL API, we call database, no change, but in Cassandra, we call it key space. In Mongo and Gremlin, we call database again. But if we talk about container, for SQL, it is container, no change. But for Cassandra, it's table. For Mongo, it's collection. For Gremlin, it's graph. For table, it's table. And similarly, for item, if we're talking about SQL, it's document because it's JSON documents. For Cassandra, it's row because it was table in the container. You see, that's how you can relate it. For Mongo, it's document again because it's a JSON document. For Gremlin, it's node or edge because these are like graph where the nodes and the relationships would decide with the vertices. And for table, it's item. So you see these things, the structure, the name of these structures, database, container, and items would be changed as per the APIs. Okay. All right, this is also an interesting topic. Now, the most interesting topic of the Cosmos is coming, which is partitioning. And we need to get the pen back. All right. Now, in Cosmos DB, we have container and we interact with the container. We read the data from the container. We write the data in the container. Basically, container is the service through which we interact and we can store data in a container. Now, behind the scene, these containers may have one or more physical machines. Now, we need to understand the structure. At the top level, it was database that we have already talked about it. Then we have container. Now, this is the internal structure that we do not see, but it is taken care by the Microsoft. We only take care of the partition key. On the container, we decide when we are creating the container, we also create the partition key. And this partition key is responsible for what? For logical partitions. And these are logical partitions. These are logical partitions. And these logical partitions are mapped with the physical partitions right here. And if you see closely, you'll find you have more than one logical partition mapped with this physical partition, but it's not the other way around. Like one logical is not connecting with the two physical partition. Okay. So this is the basic structure behind the scene. Now, Cosmos DB takes care of machines required to handle the storage and throughput needed by the container workloads. If we add more data in the container, let me switch to laser pointer. Now, if we are adding more data in the container, the Cosmos will manage more physical machines. Okay, so whatever query we write, it would divide the work into these machines. More machines we have, more parallel query can work, and this is how the Cosmos DB become horizontal scalable limitlessly. Now, stay with me. Let me take you through this this structure once again, so that you would have this concept clear in your mind. Okay. Now, as I was saying, we only interact with the container. And when we create this, we also create the partition key. Now I'm explaining this with an example to make it more understandable. So let's say if we have a user in this different users, the data that we have, the data has different users along with their cities in their profile. Let's say this is the scenario. All the data has multiple users, and users belong to different cities, and this is there in their profile. Now if you select the partition key as city, let's suppose we have user in Delhi. So all the data of the users will go into one logical partition. Like all, for example, let's not say Delhi, let's say London, as per the screenshot that I took from the Microsoft documentation. You'll find it there. So let's say the city is London. So all the data belongs to the London users will come here. All the data belong to the New York users will come here. Same goes with the other cities. And here it is divided as per the airport. Okay, so we have to define the partition key, and it is very simple. We can define it with respect to partitioning. Well, partitioning is the items in a container divided into distinct subset of data called logical partition, and the key which divide the data is called partition key, if we have to explain it. Okay, now once again, as I said, one logical partition cannot be divided into two physical partitions, but more than one logical partition can end up in one physical machine. It may possible, like for example, these are connected to this physical machine and this data is keep on growing. Now it may possible Cosmos DB will move this logical partition to another physical machine, like in absolute, in entirety. It's not like it will connect to two machines. This concept we need to be very sure about. Multiple logical can have physical, but multiple physical cannot have a single logical. Let's put it this way. Okay. Now that's how it's gonna work. So this is what is happening behind the scene. Whenever you're working on the Cosmos DB, these things are gonna take care of on the performance of the application, on the pricing of the application. So you gotta be smart. You gotta be very smart in choosing your partition key, because partition key will decide, how the database is segregating, and these segregations connecting to the compute. So in next slide, we will understand few concepts that we should be aware of before deciding the partition key. Okay. Now, the very first is hot partitioning. I need my pen back here. All right, so hot partitioning. Let's try to understand the hot partitioning. Let's suppose these are three logical partition. Okay. Now, let's suppose you choose the same. If we go back, same example, you chose the city. Let's suppose Rome, which is the bigger one. Now, if you are choosing the city where the maximum city as a partition key, and your user base is not evenly distributed in globally or in all the cities, then what would happen? Let's suppose you chose the Rome as per the previous example, and Rome where the maximum users are. So what would happen? This logical partition would have too much data, right? Because everybody belongs to Rome. And these one would have few. So what is happening? This logical partitioning is becoming hot. It is taking care of all the data. Every data is going to this logical partition, and these are just sitting there, not doing anything. And let me tell you this. Let's suppose you have 1,000 RUs at the container level. We have container here, and the unit of throughput here in Cosmos is request units. Just like in data warehouse, we have DW in Azure. There is one more like DTU, the old one of the Azure SQL database. Similarly, in Cosmos, we have RUs. Let's suppose if we have 1,000 RUs assigned at the container level, it will get evenly distributed to these. Okay, So let's make it 900. So it would be 300, 300, 300. Now only this distribution is getting all the database. Just think about it. It will consume all the RU, and it cannot borrow the RU from these logical partition. These are separate. They will not share their RU with this one. You're getting my point? So it will be interruption. It will not be a cool key. It will not be a good key. It would not be a smart way of deciding the key. So you should be aware of the hot partitioning. Your key should not lead to the hot partitioning situation. Okay. So this is what the hot partitioning is. I hope this concept is clear. Now, just think about it. This particular concept, where is my pen? Where is my pen? I can see now. This particular concept we were trying to understand as per the perspective of storage. Okay. Similarly, we also need to keep in mind the throughput. We don't want hot partition as per the throughput, just like in this example, because this is happening through the storage, but same thing we do not want as per the throughput. It was hot partition with respect to the storage. What do I mean by that is when we run query, it should always getting output from same logical partition rather than spread to other partitions as well. So what I mean by that, let's take the same example, these three logical partition. If I could remove it. Yes, very well. Now we are talking about the single partition here. Oh no, go back and enable the pen. All right, we have these three logical partition again. Okay. And we are running some query here. Now, at the back end, these are connected to the physical machines. There are physical machine at the back end. We already understood in the previous structure of Cosmos. Now, if you're running a query and that query goes to this partition and get you the data, that is a beautiful partitioning. That kind of partitioning you want. But let's suppose you run the query and it has to go here, oh, and then go here, oh, and then go and reference this as well, and then giving you the data. Just think about it, the complexity and how much RUs it's gonna burn for you. So this kind of query is called cross partitioning query, and in the single logical partition is called single partition query. And we do not want our queries to go and keep getting reference from the different logical partitions, because it's not good. It will take time, it will consume RUs, it will impact the performance of the application. But you must be wondering, how can we get rid of that completely? Well, that is for sure is not possible, but we still try that we would have minimum cross partition query. Okay. So that is what the cross partition and single partition query. We understand the concept of hot partition. We don't want that. Single partition query, we want that. Cross partition query, we try to avoid that. And we have to choose such a key which will have these things that we are talking about. And the last one is the composite key, which is gonna be interesting because Cosmos DB do have restrictions. We got two restrictions in Cosmos. Okay. The first one is document. Each document cannot exceed the 2 MB of data. And each logical partition, for example, this is the logical partition and these are the document here. This document cannot exceed the size of 2 MB, and this logical partition cannot exceed 20 gigs of data. These are the restrictions. Now, let's suppose you have chosen a key. For example, the hot partitioning key. So of course, your data inside this logical partition is gonna be more than 20 gigs, right? Because it's hot partitioning. So let's take an example of something like these are the logical partition for you again, and you're choosing, let's suppose, username of as a partition key, and as per username, data is dividing into different logical partition. Now, after couple of months, you may realize like it's getting bigger and bigger, bigger and bigger. People are uploading pictures and things like that. Then what we're going to do, because this will hit the restriction point. So you need to be very wise and prudent at the time when you're deciding the partition key. You need to think future, you need to know your application, and then you choose the partition key. So in these kind of situation, we have something called composite key. So what we're gonna do in the composite key, well, we have the idea, we're gonna add along with the username as like dash month, date, year as a partition key. Now you must be wondering, this will create enormous number of the partition key. And let me tell you this, it's okay to have n number of partition key because ultimately they are connecting with the physical machine at the back end. Okay, so this is okay to have n number of a logical partition because you chose such a partition key. This means each time user visit a website, that will create a separate logical partition if we choose dash month, date, year. Now, if you're thinking uh, about this, if we would have so many logical partition, because every time the user is hitting the website, the another partition is creating, this will, if you think from the structure perspective, all those logical partitions is basically data. It's not getting double, it's not getting a triple, it's the data. It's just a segregation, that too logical, but it is mapped with the physical machine at the back end. The segregation will help you in running your queries and saving your RUs, getting the performance back. So having many more partition, it's perfectly fine. So once again, the purpose of composite key is we further trying to divide our data into different logical units. Further want to shorten the size of logical units or logical partitions so that we would be inside the size or inside the restriction limits of Cosmos. Okay. Now let's check. Where is this gone? Okay. Sorry guys, this is my pointer. I couldn't see because I chose the point one. Now here we have discussed all the concepts which are there, which are needed to understand. But now it's time to choose the partition key. Okay, because we understand the concepts on the basis of which we have to decide the partition key. Now it's time to choose it. So choosing a partition key is very important, or rather critical, because this is something we need to define at the time of database or container creation. Once we define it, it's not possible to change the partition key later. If you have to choose the partition later due to some reason, then we'll have to create a separate container with the new partition key and then move the data from old container to the new container, which is sometimes, of course, not easy and interesting thing to do, right? So you gotta be very wise and prudent. We need to keep in mind, all right, where is the right here? These things. We need to choose the partition key which will evenly distribute the storage so that we would not have the hot partitioning. It will evenly distribute the storage. We will choose the partition key which will evenly distribute request so that we should not have all the queries going through all the different logical partitioning and making it cross logical partitioning queries. And we need to keep the limits in mind. Remember, 2 megabytes for the document and 20 for the logical partition. And it's not like it may change in future, but for now, this is the limit. Okay, so these things we need to keep in mind before we choose the partition key. We have already understood the concepts of evenly distributed storage because we don't want hot partitioning. We understood the evenly distributed request because we don't want cross partition query, and we always keep in mind the limits, right? Now let's go and explore a few important aspects towards the performance of this Cosmos DB. The very first is the latency. So what is latency? Well, in simple terms, it's the response time, or how fast is the response for a given request. Or latency simply means wait time. Now, who is waiting here? It's user who is waiting here, okay? All right, so the best possible way to reduce the latency is to deploy your server near to the user. We already talked about it at the beginning. Now, the next thing is the throughput. When we when we were discussing about the latency, we discussed about it from the user perspective, right? And throughput is more from the database perspective. How? Okay, this means how many requests database can handle per second, or how much workload a database service can handle. This is called throughput. So it is coming from that perspective. So how fast request is getting is latency, and how many requests are served within a specific period of time is throughput. Okay, and unit of throughput we talked about in the structure. It was request units, RUs. That's the measure of the throughput in Cosmos. And RU, or the request unit, is a combination of memory, CPU, and IO, just like any other units like DW or DTU. Okay. Now, horizontal scaling. We already uh, have the idea when we're talking the structure, like, logical partition and the physical partition. As much as data you are entering in the container, as much as physical machines are getting created at the back end by the Cosmos. What was happening? It was horizontally scaling the Cosmos. Okay. So what was the another one? That is automatic indexing. We did talk about a little bit at the beginning when we were talking. We were saying it's more like a SaaS because it also does these things. So Cosmos DB takes care of all the indexes. Cosmos DB by default create index on all the data without your interference, without any kind of index management. So all the items, all the records, all the property of the records, everything indexed automatically without doing anything. Okay. Now, time to live. Well, it's interesting because you don't need to delete the data that after a certain period of time, maybe it's old, or maybe you don't want that data. There is a feature, or there is this time to live option that you can opt for. Okay, so with time to live, TTL, Azure Cosmos DB provides the ability to delete items automatically from a container after a certain period. This time to live value is set in seconds, and it is interpreted as a delta from the time that the item was last modified. So if you're wondering why TTL is in performance section, because everything is related to performance, let me tell you this. Deletion of the data also consume RUs, and TTL uses the leftover RUs. Request units that haven't been consumed by the user request. It will use those RUs and remove the data as per the condition configured, or the time period configured. Okay, we are almost there about the Cosmos. It's a big topic, so stay with me and let's try to understand the change feed notification. So as the name says, what do you think it will be doing? Well, if you're thinking that it would definitely do something related to the changes happening inside the Cosmos DB, then yes, of course, you are correct. Change feed keeps track of all the changes or modification in the container and outputs the stored list of documents that were changed in order in which they were modified. You can see all the inserts and updates in the change feed, but you cannot filter for a specific time of operation. However, you can add a soft marker on the items and filter based on that when processing item in the change feed. Now, one more important thing, currently change feed cannot make the entry of the deletes. You can go with the same soft marker thing, but it's not there as of now, maybe in future. So some of the common use case of the change feed is replicating data from Azure Cosmos DB as your primary or store to some other secondary data store, like a hot store that you're using, the primary one, but you also have the a cold, the secondary one. You can have that replicating these changes from your primary to the secondary. Okay. The simplest way to consume the change feed is by using Azure Functions with the Cosmos DB trigger. Well, with this topic, let's finish the Cosmos DB session and jump to Blob. If you were with us in the beginning, these two are the agenda, and it's time to hit the next module. I think we are On time, maybe a little late, but I'll try to manage, try to complete on time. So let's hit the next topic, blob storage. Well, as always, we need to understand with the help of overview what it is. So Azure Blob Storage is Microsoft's object storage solution for the cloud. Blob storage is optimized for storing massive amounts of unstructured data. I'm repeating it again because this is very important. Unstructured data. Okay, it's an object storage. So unstructured data is not adhered to any particular data model or definition, such as text or binary data. For example, a blob can hold a PDF document, a JPG image, a JSON file, a video, etc. So that's what the blob storage is, and blob stands for binary large objects. And if you're coming from the AWS background, they call it S3, simple storage services. So users or client application can access objects in the blob storage through HTTP or HTTPS from anywhere in the world. Well, don't be afraid. You would have all the permissions in your hand. You can decide who can access, who cannot, but it is there. So objects in blob storage are accessible through the Azure Storage REST APIs, PowerShell, CLI, storage client libraries. And an Azure Storage account is the top level container for all your Azure Blob Storage. Okay, let me go to the next slide. So what I was trying to explain, it will come later as well. That's why I stopped the structure. When we're talking about the structure, we would have what is top level and what is, again, just like in Cosmos, we had account, then database, then container, then items. Similarly, in blob, we got to have storage account, then container, then we're going to put the blob. It will come later as well. So we need to create this storage account first before we have the blobs in place. So that's why I put this to understand there are like different storage accounts, and one of them is also deprecated. It was there. It was Microsoft was giving option to even migrate it to V2, update it to V2, but I think all are updated as of now. That's why they deprecated. But it doesn't matter what we are, why we are here. We are here to understand the various storage accounts which are available right now as per our certification path. We got general purpose version 2. This is basic storage account type for blobs, files, queues, and tables. All four things that Azure Storage Account caters. And this is recommended for most of the scenarios, version 2, because it has all those features like access tiers and all. We'll talk about that in coming slides. Do have premium blob. It's a premium kind for high transaction rates or scenarios that use smaller objects or requires low storage latency. Similarly, we have file share, just like network drive you hook up with the virtual machines. That's the premium file share, which is recommended for enterprise or high performance scale applications. And similarly, the page blobs is premium now. This is where we store the VHDs, the page blob, only for the VHDs. So let's quickly move ahead and check the redundancy, which is the most important part of Azure Storage Account, which is the most interesting feature and makes an Azure Storage Account so awesome. Because it's not one, not two, but three copies. And let me get my pen first, then I'll do again. But three copies of a single file that you're uploading gets 3 copies. In LRS, all 3 copies are synchronously replicated in a single DC. Okay. In ZRS, same thing. It's a synchronous replication and 3 copies across 3 zones. And in GRS, it would be more interesting because now in all these 4, we have 6 copies. Why 6? Because 3 copies, just like these 2 GRS would have, but it's geo redundant. Geo means a different region as well. So let's suppose this is one region and this is another region, and we have chosen the GRS. So in one data center, there are 3 copies, even for GRS. Now, we also need to send it to another region because it's geo. So it will asynchronously send the copy here. And now it will again become 3 here in this data center. So it's 6 copies. Now, these 3 is the most important to understand because you can easily relate the other 3. If you know what GRS now, it's geo-redundant because it's in another region as well. Just add, you would have the read access to these copies now. You can also read it. So that is read access geo-redundant. Now, this is happening as per LRS. In a single data center here, single data center here. But make it zone. Then it will become GZRS, like 3 zone inside this 1, 2, 3, and this is asynchronous. Then again 1, 2, 3. Now if you have the read access of this zone, then it will become RAGZRS. So inside the region, it is always a synchronous replication. That is very important. And outside a region, it would be asynchronous to get to the another region. And then inside the region, it would be again synchronous. So for geo, it would be 6 copies. For inside a region, it would be 3 copies. So it's a very, very important and interesting feature that makes storage accounts so powerful. Now, let me get back to my laser pointer and understand the types of blob, because this is the blob solution, right? So we need to know the kinds of types of blobs which are available. So we got blob, append blob, and page blob. Blob store text and binary data. Blobs are made up of blocks of data that can be managed individually. Blob can store up to 190 TB. I remember it was like 4 point something TB at the beginning, but now it has reached up to 190 TB. And append blobs are just like blob, but it has this this feature or that it can append the operations. Append blobs are ideal for scenarios such as logging data where we do not want to erase the data. You want to keep on writing below the data whatever is there, like it's appending the data. Now page blob store random access files up to 8 TBs. Page blob store VHDs files. If you remember when we were talking about the storage account, there was the premium page that was for the VHDs. So that's what it is. That blob it is, the page blob for the VHDs, for the virtual machines. Now, it's time to understand the structure that I was talking about at the beginning, but I think I already told you, but slide is here. Let's go ahead and have fun with the slide. So this is the storage account. Let's suppose you create, and under the storage account, you got to create the container. Inside the container, you have blobs. So this is the structure. This is top level. We create container, then we create blob. And whenever you create account, this is a unique name. Okay, this is the unique name. For example, and this unique name is going to append with your blob. It is more like if your storage account is named as like Azure EZ, then it would be the endpoint for your blob storage would be Azure EZ blob.core.windows.net. Okay. So Azure Storage account provides a unique namespace in Azure for your data. And every object that you store in Azure Storage account has an address that include your unique name. Okay, cool. So access tiers, that is one of the most interesting feature again. You must be wondering, I'm finding everything interesting. Well, it is interesting. All right, so let's try to understand hot, cool, and archive. Well, Azure Storage provides different options for accessing blob data based on the usage pattern. Each access tier in storage is optimized for a particular pattern of data. By selecting the right access tier for your needs, you can store your blob data in the most cost-effective manner. So we need to understand that what is hot storage or like hot access tier. It's not storage, my bad, it's access tier, which is optimized for frequent access. Okay, of objects in the storage account. Accessing data in the hot tier is most cost effective because we are using this for the frequently accessed data and it is most cost effective. while storage costs are little higher as compared to the other ones, other tiers, I mean. So new storage accounts are created in the hot tier by default. This is the default tier of the storage account as well. Now, cool access tier is optimized for storing large amount of data that is infrequently accessed and stored for at least 30 days, because if you pull the data within 30 days, you still have to pay for the 30 days. So that's the trick. So storing data in the cool tier is more cost effective, but accessing the data is a little more expensive than accessing data in the hot tier. Okay. Now you would have pretty good idea about the archive now, which is available only for the individual block blobs. These things you can choose on storage account level, but this cannot be happen. This happens on the blob level. Okay. The archive tier is optimized for data that can tolerate several hours of retrieval latency and will remain in the archive tier for at least 180 days. The archive tier is most cost efficient option for storing data, but accessing that data is more expensive than accessing data in hot and cool tier. So why we are talking about these tiers? Well, we are talking about this tier because there is something called it would be the next slide, but let me show you here. There is something called a life cycle managing the blob storage. And we can decide how our data will be here. If it is a frequently accessed, it will remain in hot. If it would, let's suppose after 30 days or after 15 days, nobody's accessing this data. You can create a rule and put it in a cold storage after the time period when people are not accessing. You put that in the cold because people may access, so you wait for another 30 days. Let's suppose you can decide the days as per the need, as per the uh, requirement of your business, your organization, your people, how they are using it. So you can move after, let's suppose, 30 days into archival. And this thing is called lifecycle management, and you can easily do this with the help of Azure portal and the various means that we access the Azure resources. You just need to apply the conditions. Okay. And if I should move to the next slide where I have mentioned manage blob storage lifecycle. So this is what the lifecycle is. So if I have to say, I would say transition blobs to a cooler storage, hot to cool, cool to archive, or hot to archive directly. You can do that as well. Or to optimize for performance and cost. This is what the life cycle is. And you can delete blobs at the end of their life cycle. You can apply that logic as well. You can define rules to be run once per day at the storage account level. You can apply rules to containers or a subset of blobs using prefixes like only text file will move, only this file will move, prefixes. So I hope this is clear now, and let's move to how blobs used by the application. That is interesting. We should be aware of this. Well, if we have to understand, blobs are used for data storage in many ways across all kind of apps and architectures. Let's talk about few so that you would have a picture in your mind, like apps that need to transmit large amount of data using messaging system that supports only small messages. These apps can store data in blobs and send the blob URLs in message. See, uh, such a beautiful way of using it. Now, blob storage can be used like a file system for storing and sharing document and other personal data. And you can also create a static website on the storage account, and static web assets like images can be stored in blobs and made available for public download as if they were files on a web server. You can do that as well. And many Azure components use blobs behind the scenes. For example, the backups, or even Cloud Shell, uh, virtual machines uses blobs for hard disk storage. All right, so even the ASR, when you do the migration, it takes care of, it works on the managed disk, which is eventually having the storage account at the back end of the blobs at the back end. Now, uh, it's time to check few some of the main classes and objects you will use to code against Azure Blob Storage. So Blob, let me get to the pointer again. Blob Service Client. This class represents your Azure Storage account. Use this class to authorize access to Blob Storage using your account access keys. Container Client. Well, this class allows you to manipulate storage containers, as the name says, containers and their blobs. And Blob Client allow you to manipulate storage blobs. And Blob Client options provide the client configuration option for connecting to the Azure Blob Storage. All right, so there are situations where you need to move your data between the containers or the storage account. Well, Azure doesn't include any processes to move blobs. To perform a move, you will first copy the data and then delete the source data. And Azure does provide several tools you can use to copy blobs to destination. And these are the tools that you can easily utilize for the purpose of copy or move data. Well, you transfer blob between containers and storage account using AZ Storage blob copy command, that is the CLI command. Unlike the upload and download operation, this command runs asynchronously and uses the storage service to manage the copy processes. This means you don't have to download and upload blobs through local storage to migrate them between the accounts. You can track the progress and cancel the operation if necessary. AZ copy utility was written specifically for transferring data into, out of, and between the Azure accounts. We have .NET Storage Client Library as a collection of objects and methods that you can use to build custom application that manipulate items held in the Azure Storage account. And this is failover option, which is not like copying something, but you can utilize to move not the items, but the entire storage account to the different region. If you remember the redundancy that we're talking about, let me get my pen to, let's suppose this is your storage account and you made it GRS and you have one copy replicating asynchronously in another region. You have an option of failing it over because you do not have access to these files. So you can fail over. Now you would have this endpoint for you to utilize your utilize in your application. Let's suppose this region is down or something's happened, so you can fail it over manually. So what is happening? It's even if it is not down, you want your data to be moved in a different region. You can utilize this feature, the failover one. This is only in the geo replication or geo redundancy options like geo or GRS or GZRS. Any geo redundancy option you can opt for the failover, and you can move your data from one storage account to another one in another region. Okay. And this is blob container support system properties and user-defined property, user-defined metadata, in addition to the data they contain. Okay, so these are two additional things. Well, what is system properties? System properties exist on each blob storage resource. Some of them can be read or set, while others are read only. Under the covers, some system properties correspond to certain standard HTTP headers. The Azure Storage Client Library for .NET maintains these properties for you. And user-defined metadata consists of one or more key value like name value pairs that you specify for blob storage resource. You can use metadata to store additional values with the resource. Metadata values are for your own purpose only and do not affect how the resource behaves. Okay, so with this, let me end the theory session. I hope this is interesting and I hope you learned something new. I'm pretty sure Cosmos was very intense because most of the people are always aware about the storage account. So this could be repeat for you, but I'm pretty sure not the Cosmos one until you're working with that. So with this, let's take a break and afterwards enjoy the lab and try implement at your end as well. Do wait for the recording because you may need to go through recording a couple of times maybe to imbibe everything in there. You can also check my channel, Pachara Talks, where I do have explained a lot of topics, including Cosmos, that could be beneficial for you. And so grab a cup of coffee or tea and let's meet after a break. And yeah, we all deserve that break now. So meet you after 10 minutes. Thank you, everyone.
Thanks, Aaron. Okay, so we are going for a 10 minutes break after very topic and well discussed things here. So let's go for a 10 minutes break. Let's take a coffee break or have some rest, and then Sanjeev will be joining us for the practice session. I mean the demonstration. He will take some of the use cases that we have discussed so far. Arun has taken the conceptual part of it, and now Sanjeev will be showing you the coding part of it. So be prepared. After 10 minutes, we are again coming back. Thank you. All right. Thanks everyone. Thanks for waiting. So now we will join by Sanjeev. So Sanjeev, you there?
Yeah, thank you,
Yeah,
Ashish.
please go ahead and share your screen and let's get started.
Yeah, sure. Yeah. So thank you, Ashish, for providing me this opportunity to go through the practical scenarios of the blob storage and the Cosmos DB. Thank you, Arun, for providing a nice session on the Cosmos DB part and the blob part. Now we will go through the how we can programmatically play around the blob storage and how we can play around with the Cosmos DB. We'll go through both of blob storage and Cosmos DB in 45 minutes or 1 hour session. So let's go ahead and check it out. Let's go ahead and create a storage account. As you guys know that storage account is a key component, or I can say a backbone of the Azure. So let's go ahead and create a storage account. All you know that you can create a storage account from here. I have already created a storage account called Media Storage Azure Easy here. So you can always go ahead and create a new one and put a new resource group, or you can add it to an existing resource group. And you can provide the storage account name. And we last time we covered about this performance and redundancy, all this thing about the storage account. So I'm not covering those things right now. So as I already have created the storage account, when you create a storage account, you can have the data storage of tables, queues, file shares, and containers. Today we'll be mostly playing around with the containers, which is like you can create blobs and upload the blob data into the containers. So from here, when you create a storage account, you always have the access keys where you have the two of the keys. You can we will be needing it in future, like around in 5-10 minutes. So I will be these values will be needed. So I will be copying it and I will have it handy with me. So you always need the access keys and the keys, like the connection string and the keys. So let's go ahead. I have a container, so you can always create a container like from here, whether you want to create a public access private container, or you want a blob with anonymous read access, or you can create the private containers. So you can give any names here, XYZ, ABC, as per your requirement. So here I have created two containers called demo AZ-204, and one container called raster graphics. So you can always create from here. It takes very less time. So I have my setup the Azure resource part ready, so that I can go through you the .NET coding part. Like you can play around with .NET, Java, Python. Azure gives its SDK to programmatically interact with the Azure resources. So now we will be playing around with Azure Blob. Uh, so here is my simple console application which I have created, and as I told you, I have the connection string needed. So I have put it here, and I have my storage account here. So in next 20 minutes, we will be entirely covering the blob storage. And we'll be fetching the data from the blob storage. We'll be trying to upload data, we will try to fetch the uploaded data, and it will be an interactive session. Let's see, and what we have in our. So to connect with any of the if you are in any of the programming language, most of the programming language supports package management concept. So if you are into a developer background, you might be knowing it. So like in the .NET world, we have our package manager called NuGet. So here we will be adding the NuGet package called Azure Storage. Let's go ahead and add it. Let me, yeah. Okay. So here we will be trying to connect with the Azure Storage. So here we will be, I will be creating a object called like, I'm not going into the programming concept anymore because it would be a very difficult task for me to cover all these programming things first. But I'm directly creating an object of Blob Service client, which is provided by the Microsoft SDK. So let's go ahead and create it. So here I'm just creating an instance of the Blob Service client, which needs a connection string. So I will be providing my connection string here. So now my instance of Blob Service client is pointing to the connection string, which I have copied from my other instances where I showed that you can copy that and put it over here. So now let's go ahead and do account info equals to await service client dot get account info async. So I'm because we will be playing around with the Azure resources, and we will be doing it in an asynchronous manner so that our performance would be good. So I'm not going into the details of the asynchronous programming. I'm just giving you hints that I'm using it. So now let's print something into the. As we have taken the information about our storage account, let's print the info dot. You can say, let's say the SKU none. So this would be. SKU. Let's go ahead and pick. Okay. Okay. So now let's see what it prints. We will see. Let me put a debugger over here. Yeah, if you see, my info has the account kind and the SKU name. So this is just fetching it from the Azure resources itself. So this is the simple way to connect it with Azure storage account, you can say. So now let's go ahead and pull out all the container names we have in our Azure storage account. So we'll go ahead. Let me write a method called private static async task. Let me go ahead. Let's name it as enumerate containers, and being an asynchronous, and let's give it the reference of Blob Service client so that we can use the client over here, and let's put a for each loop, and we can say where container in. So this blob service client gives us all the method called get blob containers async to get all the containers information from our. So let's put it like this way. I'm copying this one. So let's go ahead and do that. What are the container names we have? So let's do it like this. Container dot name. Let's go ahead and let's call this method from here, from our console application, so that we can know, we can call it. It should be service client. So let's make it as available, so that, okay, we are good to go. So now let's go ahead and I'm removing the, so that, okay, let's see what are the, I think I created 2 containers over there. It should print the 2 container name. Yeah. So if you see, it is it is putting the container name as demo AZ-204 and raster graphics. So let's go ahead and check it out if we have these 2. Yes, if you can see, I'm just pulling out the container names from here. So this is the easiest way to playing around with the blob service client. So we'll be doing the if we have inside a container, if we have some blobs, then we will be pulling that out as well. Let's go ahead and upload some data into the blobs. So let's say inside this, I am uploading a blob called, let's say, my print receipt. Let's upload it. So now let's create another method called private static async task enumerate blob async. So here we will be passing same blob service client, because that's our main reference point to interact with the storage account and sorry. So let's pass the container name, from which container name we want to get all the blobs. So let's go ahead and we need to create a container instance now, equals to new. So we have, no, sorry, that's client dot get blob container client we have, yes. So now let's pass the container name. So here what I'm doing, I'm asking the blob service client to get the blob container client, which will give me an instance of the blob container, particular blob container client. Let's say we have inside we have demo AZ-204, or we have raster graphics. So like I'm just passing, you can pass any container name here, and it will give you the exact container instance of reference to that container instance. So let's go ahead and do a await for each loop. So let's var item equals to var item in. So we can set that container dot get blob async. So once we have the container instance, we can Microsoft SDK provides us get blob async method to get the blob information out of an container. So inside that we can write await Let me copy this one. Sorry, I'm not. I'm just copying it so that I can save some time. Sorry for that. Yeah. So, like I can say that the existing blob is, let me put a dollar symbol here so that we can use the inline. Yeah. So we can say that the blob name, that is the item dot name. Yeah. So let's go ahead and call this method as well so that we can see if it is printing anything or if we did some mistake. So client, let me, sorry, this would be service client, and container name would be, let's demo AZ-204. So let's await it because we are doing the asynchronous programming. So let's see if we will succeed. We'll put it in a debug mode and we'll see. Let's close this one. So let's debug this one. Yeah, I think we got something. If you see, we have the existing blob called print receipt underscore parts doctor PDF. If you see, that's the same blob which we have here. So we are just we uploaded that blob and we try to fetch it programmatically. It's very simple. Like you create the blob service client instance, then you get the container instance, then you play around with all the blobs which you have uploaded. So let's go ahead, and so this is the way. Then we can do one thing, like we can create the containers as well. So let's go ahead and create a container in our storage account. So let me go ahead and create another method called, so this will return me, I think, blob container client. So yeah, so let's go ahead, container. We'll try to create and get the instance of that new container which we are creating. So the whole engine of the blob interaction is the blob service client. So we need that here. So I'm putting the blob service client. So I'll put here. Then you can dynamically give any name to here, container name. So what we can do, we can say where container equals to new, sorry, we can say client dot get blob container client. So here we will pass container name, which we are getting into our method. So let's then do await. It gives us a the container instance now will give us a method called create if not exists async. So this method, what it does, it just try to check if that container is not doesn't exist. It can create that container. So I will be providing it as a public public access type dot blob. So here it, then I can just return the container, the new container instance, because it is created. If it is not exist, sorry, sorry, I did a spelling mistake here. Yeah. Okay, so let's check if something we can create from our code itself. get container async. Let's give it as demo AZ-204 6 June. So something like that. We need to provide the service client also. Yeah, now we are good to go. So for time being, I'm just commenting these two because we have already seen this. So let's go ahead and check if our code works. We can see in the Azure portal itself that whether that container got created or not.
So as Sanjeev is showing you the the how you can use the programming languages to access or to manipulate the things on the Azure, whether it is storage account or he will be showing further some other things. So I mean, from the exam point of view, you might be wondering that what exactly the expectation might be. So the expectation would be from the exam point of view that you must be knowing some of the libraries that Sanjeev is trying to create when he is trying to interact with the storage account. So those library name, those those functions name being exposed by the classes when he creates like service client, when he's creating a service client, or when he's trying to write the data on the blob. So what exactly the function name he is trying to access, those keywords, those names or the libraries, those are the things you should be expected where question might come, where you might have to either select a particular function appropriately from a MCQ, or maybe drag and drop. You might not be required to write the entire code, but you should be comfortable enough to recognize that particular code. That's what the expectation would be from the exam point of view. Yeah, please, Sanjeev, go ahead.
Yeah, thank you, Ashish, for covering that. That's why I was going through the code so that at least when you see it in the exam, so that you can recognize that, yeah, like this is the class we use, this is the methods we use. So that's the whole purpose. It's not like you have to remember everything. That's the whole purpose of doing the session. So yeah, like as I mentioned that we created this container of blob type just at 10:37:21. I didn't create it from the from just clicking the plus container add button. I just created it from the programming point of view. So that's how we do this one. So now let's go ahead and this is how you create the containers. Now you can access the blobs inside the container also. So it's not like I think we have seen that we just have gone through the how to fetch the items from a existing blob. So that's how normally the storage account, these are the building blocks of storage account. You can do a lot of things out of these SDKs. So I think that's the most part of the storage account practical scenarios we have it in this session. Now let's go ahead and check the Cosmos DB section. So in the Cosmos DB section, what we will do, we will create a SQL Server instance, and then we will try to build the data, take the data out of the SQL Server and put it into the Cosmos DB. So let's go ahead and create all those. Let's play around with the SQL Server instances. Like in this case, I have my setup ready because creating those SQL Server instances and putting the database into the SQL Server, it's a time-consuming task. So that's why I have my setup ready, but I will take you through how to create those things. So whenever you want to create a SQL Server instance, you can go ahead and create it from here. When you click on the new button, so what it does, it asks for the resource group and the database name. And if you want to create a new SQL Server pool, you can create it, give it a new, or if you have an existing one, you can use that. So this is how you create a SQL Server instance. So here, what I have my the AdventureWorks SQL database sitting inside the PolySQL Server 6 June server. So this is inside my resource group called, let me go ahead and check which resource group I have put it. Yeah, I have put it into the Polyglot data resource group. So from here also you can go ahead and create the SQL Server instances and play around with it. You can give the database name, you can give the SQL Server name, and when you give the new SQL Server, the server instance name, you need to give the password and confirm password, because that's how you will be connecting it with the SQL Server instance. So I have my SQL Server created over here, which is called the AdventureWorks. Then we need a Cosmos Db instance where we'll be, because we need to put it into the, we'll be fetching the data from the AdventureWorks, and we'll be putting the data into the Cosmos DB. So for that, as we need, we will be putting it into the Cosmos DB. We need a Cosmos DB instance also. So let's, if you go here, you go to the Azure Cosmos DB. You create on the new. So here is I think Arun covered finest session on the Cosmos DB section, where he went through like Cassandra, Gremlin API. So these are the options available for you. Like if you have a Cassandra database and you want to migrate the Cassandra into the Azure Cosmos DB, you can use that. But as we will be playing around with SQL Server database, we'll be using the SQL Server API. So we cannot cover all the all the APIs. It's almost similar for everyone. So I think if we'll cover the SQL one, then I think you guys can play around with other APIs when you have time. So you can create, you can choose the SQL core SQL, and you can give the resource group here. You can give the account name here. So that I have already created the Cosmos DB instance over here. If you see, I have a PolyCosmos 6 June. So I think when I was playing around with it, I had some data. So let's go ahead and delete everything, put it into the baseline mode, so that we don't get confused. Okay. So once, sorry. Yeah. So once the SQL Server instance gets created, I have taken the SQL Server backpack file from the internet to import that database into the SQL Server instance. So if I go to here, the AdventureWorks, so I have imported the AdventureWorks database into here. So because let me show you the query editor preview. So let me go ahead and take the password. Yeah. So this is the password I have given. So if you see, I have imported the database into here. To the SQL Server. It's not that you can you need to create the SQL Server instance here. You can create it locally. I will show. I have the local database also. I can pull the data from the local database and put it into the Cosmos DB. It's not like I need to go with the Azure database only. But as we are in Azure scope, that's why I'm showing that I have the database over here. I will be connecting it with this DB, and I'll be pulling the data from the Cosmos SQL Server and putting it into the Cosmos DB. So you can copy the connection string from here. This one you need to just put the password. Give the password which you have given in your file creating the SQL Server instance. You might have given you must have given the your SQL Server password. So all the database which is inside that server, you need to give the password. Say they will be sharing the same password. So that's what I have copied it from here. And I have my solution ready because it's a big solution. Building it in the demoing while demoing will be a very difficult task because it will take a lot of time. So let's go ahead and check it out what I have. I will be going through one by one line of code. So there is nothing to worry about that. So I forgot to show you when I created the Cosmos DB. So when you create a Cosmos DB account, you will be having the similar connection keys and all. So that's what I have taken the primary connection string from here, and you click it and copy it, and you put it over here. So I have the Cosmos connection DB string, and I have my SQL DB string ready, so that I can pull the data from the SQL Server and put it into the Cosmos DB. So my Cosmos DB is currently, it doesn't have any container or it doesn't have any document. So that's why we will be creating the container programmatically. Then we'll be creating the documents, and we'll be putting the, we'll be going through all this while demoing it. So I think if you are a developer, you can directly make raw SQL queries, and you can pull the data. But here we will not be writing the raw SQL query to pull the data from the SQL DB. We'll be using something called ORM technology, like the object relational mapping. Because being a developer, writing SQL queries would be a very difficult task. That's why Microsoft and in the new area of technology, we have the ORMs like the Dapper. We have Entity Framework for .NET. So we will be using the entity framework, which is called an ORM, the object relational mapping. What it does, it exactly takes your, if I say it in a layman way, it exactly takes your all the objects from your database and creates the classes for it inside your code. So as we are using the while you are using the ORM, you would be having two approaches. One is your database first or code first. So currently we will be using database first approach. I don't want to go into all the details because it would be a very time consuming task. But how I generated the database models from the SQL Server, you just go ahead and go to the NuGet package, add the entity framework tools. So let me go ahead. Yeah, so you need to add the Microsoft Entity Framework code.SQL Server. So that is what you need to interact with your SQL Server instances. So here I created the models out of the package manager. So you just need to give the command this one scaffold db context and pass the SQL Server connection string. It will create all your models from the database itself. So if you see, it has created all of the models for me. I didn't create it manually. So you just need to, I think these things are openly available in the internet as we are in the .NET world. That's why I'm just showing it. For Java, it would be different. I think based on the programming language, it's different. So let's go ahead and check what exactly we are doing in the program.cs file. So what I did, I just created I have given the connection string to my SQL context. So this is the SQL DB context, which will be interacting with, this is the whole engine to interact with SQL Server database. So I just provide the connection string over here. Then what I did, I asked the engine to give me the products, like what are the products available we have in our SQL Server. So let's see what are the products available we have over here. So let me go ahead and check how many products are available. So if you see, it has 504 products available, and I am printing that value in the console itself. So let's go ahead and check. Yeah, so total Azure SQL DB records we have 504. Now, as we have the data from our SQL Server, we can push this data into the Cosmos DB now. So for that, we need to create the way we have our SQL Server engine working to fetch the data. Now we need the Cosmos engine to interact with the Cosmos DB also. So that's why I have created it here. For this to interact with the Cosmos DB, you have Microsoft provides you a NuGet package, or I can say the SDK. You need to just search for Cosmos. I think you will get it. Yeah, so you need this one, the Microsoft.azure.cosmos NuGet package. For Java also it would be there. I think Python also it would be there. I'm not sure about, I think Node.js would be there. But I'm not sure on that front. But as I'm more familiar with the .NET, that's why I'm taking you through the .NET world. So, so this is the Cosmos client is available with the Microsoft.azure.cosmos NuGet package itself. If I see, it is available inside the Microsoft.azure.cosmos. So this is the Cosmos engine, which gives you an opportunity to interact with the Azure Cosmos DB. So let's go ahead. I am just creating the Cosmos client over here. Then what I am asking, just create the Adventure Work database inside my Cosmos database if it is not available. So these methods are given by the Microsoft Azure Cosmos NuGet package itself, so you can use it. Then what I am saying you create a container called products with the partition key called reorder point. You can give the partition key as per your requirement. I think Arun covered the partition key thing very nicely. So I am asking the container to be created named products inside the database called AdventureWorks. So let's see if till this point our application works or not. So if you see here, we don't have anything inside my Cosmos. For time being, if I refresh it, we don't have anything inside my Cosmos DB. So let's go ahead and let me do continue. Let's see. Yeah, so now if we go ahead and check, we will be having something inside us. Now let's see, we have the AdventureWorks. Inside that we have the products. So, but we don't have any item because we have not fetched any item. We have not pushed any item into the Cosmos Cosmos DB. So let's go ahead and put some item into the Cosmos DB. So we have our, if you remember previously, we have our items. We have fetched the data from the SQL Server. We have 504 items. So now what we need to do, we need to transform those SQL Server items into a Cosmos item so that we can push it into the Cosmos DB. That's why I have taken a sample Cosmos class, which will have a smaller number of properties like the name, product number, color, and reorder point. So what I'm doing here, I'm enumerating through all the items available inside my SQL Server. So now what I am doing, I am transforming that the first item to a Cosmos item. And inside this, I am asking this container, the Cosmos container gives three options like the upsert async, the insert async, and I think the create async and upsert async. So in the upsert, if the item is already available, it updates. If it is not available, it creates. So you can say it's kind of insert and update. So if you see, my first item would be inside my, it returns you an activity ID. So my first item would be inside my Cosmos DB. Let's see if we have some item. Yeah. We have the item over here, like something called name called adjustable race. The product number is here. The reorder point is here. So this is how if I run this application entirely, it can go ahead and create the 504 items inside my Cosmos DB. Now it will generate another document because I am running it. It is looping through it. So now it is the bearing ball B8327 and it has some GUID. So this is how I'm stopping it because it has 504 items. It will take some time to put it into the database. So this is how you put it. You can play around with the Cosmos DB. You can take the data from the Cosmos DB and you can put it into the Cosmos DB. So now let's go ahead and check the products which we have pushed the data into the Cosmos DB. But how about if we want to fetch those data? So I have my, if you see, my Cosmos container I have created over here as a class, and I have created some methods to fetch the data. So I think when Arun provided the information to us that we can query the Cosmos DB as a SQL. So we will be using like select star from items to get the data from the Cosmos DB. Let's go ahead and check if it works or not. So I have commented my previous code. I am just trying to fetch the data now. So let me comment this out. Yeah. So let me put it here. So I just created the Cosmos context instance, and I'm just passing the connection string the similar way we did it here. We are using doing it here also. Let's see if it gives us the data or not. Yeah. Okay. Yeah. Yeah. If you see, we have two records now, like the adjustable race, and I think the other one was bearing ball or something like that. Yes, we have the data from the Cosmos. So this is the way we can fetch the data from the Cosmos DB. So I think like you can play around with the other things. I just gave an overview how things work. So this is the like the storage and storage account, the blob thing, and the Cosmos DB things which we have in this lab. I think Ashish can now take it over, and thank you, Ashish. Yeah.
Okay, thank you so much for this again. A very rich content from Sanjeev again. So today it seems like we had a lot of content. Arun took his own time to went through all the concept, and now we have the very rich content from Sanjeev about the doing the exploring the code and thank you so much for you all audience as well to stay with us. Because of this type of content that we are sharing, we have to stay. I mean, it's very difficult to cover all these things within few minutes or something. So yeah, but thanks to all the speakers and audience as well. Now it's time to kind of share the quiz before we go for the winners. Let me go ahead and actually let me first go ahead and share the winners of the last session, and then we will go for the quiz. So let me share my screen. Okay. All right. All right. So now we are going to, we have these 34 people, out of which we are going to, select 6 people for vouchers, and one person will be getting a book for, that is written by me, Azure DevOps, that is on the Azure DevOps. Okay, without, wasting any time, let's go ahead and run this wheel. Okay, let's see who is the lucky first. Okay, so here we'll soon share the vouchers with you. Let me just save it here, and let's remove this one, and then let's run the next winner. All right, Manoj, congratulations. You will be having the Azure exam voucher. Now the third one. Okay, Ravindra, congratulations. Okay, let me go ahead and run it again. So far, 3 winners. Let's see who is the lucky 4. Okay, Bhavesh, congratulations. You'll be also getting an email from us in next 1 week. Okay, so this is the 5th one. That is Saket. Saket. Sorry for pronunciation. Okay. Okay, so Saket. And this will be the last one for the voucher. That is Monica. Congratulations. And now this is the the one who will get the book. Okay, Mohsin, congratulations. I'll be soon sharing the book with you. Uh, okay, congratulations everyone. Now it's time to have a quiz for today's session, for which we are going to share the winners in the next session, just like we are sharing this. We are having a winner announcement for the previous session. Let me go ahead and share my screen for the quiz. All right. Okay, so on the screen you have a barcode and you have a URL, and I am going to share this URL in the chat as well. So just give me a moment. And this URL you can access. This will be open for next 10 minutes. So the time starts now. So go ahead and fill in the quiz. Let me just confirm it's opening for you guys. Yep, it's there. So you go ahead and fill the all the quiz, and 10 minutes we are having. All the winners will be getting, selected 6 will be getting, Azure voucher, just like we did for the previous session now. Winners will be announced in the next session, that is on the 27th. If you have not yet registered for the session, please go ahead and register on this URL. You'll be getting a notification, as well as the primary criteria for winning the voucher is that you must be registered on the Eventbrite as well, apart from participating in the quiz. So if you are still not registered, please go ahead and register on the Eventbrite as well. While you are going through the quiz, please go ahead and explore this LinkedIn URL as well after this session, maybe, where you can win a Surface Go by Microsoft if you are lucky enough. So it is a monthly raffle and it's a Microsoft initiative. Azure AZ is not running that one, but yes, you can go ahead and participate and make use of this particular opportunity as well. So, okay, so we have like so Vipin, how much time we still have for the quiz?
So we have 8 more minutes left, Ashish. We started this link at 2 minutes before, so we have 8 more minutes from now.
Okay, great. So, okay, guys. Okay, responses have started coming in. I think most of the people are still evaluating the answers from their side. We have got few responses so far. Right. And if you are still not part of our community, I would say, please join our community. Of course, we are sharing a lot of, knowledge, a lot of information, by excellent speakers that we have, but we are also active in our group, myself, Sanjeev, Arun. So if you are still having any question that is still not answered yet, because as you know, we are running the session at the same time, it becomes difficult for answer all the questions. So you can join there, you can put your questions over there. More than 10,000 people can answer your question, including us. And of course, we will learn together there. So that's the primary objective, to have that group. And we have already posted the group link in the chat. You can anytime go there and oops, looks like okay. I'm just posting the links in the chat. I forgot. Right. And also you can visit our YouTube channel for watching all the previous sessions. And as well as we will be, uploading the session recording over there. So you can subscribe to our channel to get the notification. And we will also send the email to all the registered, participant, as well as we kind of, as soon as we upload the session recording on YouTube, we also share that information on our groups as well. So if you are connected with us using either of the medium, YouTube, Telegram group, or through Eventbrite, rest assured that you'll be getting the notification as soon as we upload the recording. We still have like 4
Yes, we have 4 more minutes, Ashish.
Okay, okay, great. So after 4 minutes, this link will be disabled and you won't be able to submit your answers even if you have attempted. So please make sure that you submit your answers before it gets activated. Of course, we will tell you as soon as we will click the button to deactivate the link. You will start getting login screen as soon as we will deactivate the link. So please make sure to submit the answer, whatever you may have understood based on the questions. And the next session we will be having will be on monitoring. Let me check. Yep. The next section will be
Ashish, I think we have next session on security.
Security, yes. So next
Yes.
session will be on security and then after monitoring actually. Yeah. So next session, again, very important one for developers where we will be covering AZ-204 focus topic for Azure security. So how to secure your code, what are the things you need to know from the Azure Active Directory, what are the things you need to know, authorizations, authentication and authorization aspect of your web application if you are hosting it in Azure. So all those things will be covered. That is on the next session, that is on the 27th of June. So if you have not registered for the Eventbrite, please go ahead and register there. We still have 2 more minutes.
Yes, so we have 2 more minutes. That's the last minute to complete this particular course, and it means it also have 2 more. And as Ashish said that we have 2 more sessions for AZ-204. It means you have 2 more chance to win this exam voucher that you people can utilize to appear for any of the Microsoft exam.
Except fundamental. It's not valid.
Fundamental. Yes.
So this exam you can use for any other exam except fundamental. 204, 104, 400, 304, 303, whatever exam you can take. The only limitation is you cannot take the fundamental exam. All right, we are getting a good number of responses today.
And this is the last minute. We have few more seconds only, and post that this quiz link will be disabled for today.
Yes, I'm just going to disable it in a minute.
Yes, so the time is up now. Ashish, so we can disable the link now.
Okay, guys, so I'm going to disable it on the count of 5. If you have not yet submitted, please go ahead and submit. Last time I got complaints that people were not able to submit even though they had the completed. So yeah, 1, 2, 3, 4, 5. That's it. Okay, so it's disabled now. If you will try to submit the response, you won't be able to submit. It is giving you a login screen probably. And okay, so we are done for the quiz. Now it's time to we have already announced the winner for the last session. It's almost kind of over, we are almost like hitting the 3 hours time. And I would really like to thank all the participants actually to stay with us for this long time and staying with us for this rich content. We hope that all these things that our speakers are trying to share is helpful for your preparation, for certification preparation, as well as for the knowledge that you hope to get from these sessions. If you want to connect Arun, You can connect with him on YouTube or on his LinkedIn ID that is there on your screen. Arun has a YouTube channel where he actively publish Azure related or architecture related topic very frequently. So you can connect with him on the LinkedIn or YouTube to get the updates from him. Anyway, he's going to share the knowledge with us as well through sessions. Uh, Sanjeev is there on the LinkedIn as well. Sanjeev Sanjeev is going to help us in future, all the demonstrations, and he is a software developer. If you have any question, you can definitely connect with him. You can post your questions there in our group, or you may connect with him on the LinkedIn. Now, all these 4 links, very, very important links. The first one is for registration for our upcoming sessions of this series, AZ-204. And of course, once we will finish this one, we will probably come up with another exam, one of the most important exam maybe. The next link goes to our Telegram link, one of the largest IAM-based community on Azure. More than 10,000 people are there who help each other, globally available. Anytime you post your issues, one of the person will be from one of the part of the world will be available to maybe work with you to discuss the issue, and maybe they will try to help you out. DevOps Pro is our DevOps group, Telegram group only. More than 4,000 people are there as well, where we discuss DevOps specific things. Any kind of automation, any kind of DevOps, CI/CD, whatever it is. You can go ahead and join that group for discussion on that area. Um, the last link is our YouTube channel. Of course, that links that's where all our previous session you will be able to find. So these are the things that. And with this, I would like to thank everyone to stay with us till this time. It's really, really long time that we have discussed a lot of things. You still have questions, please post in our group. We will try to answer it as soon as we'll finish the session today or tomorrow. Thanks again. Thanks everyone. Thanks to the speaker, and let's get connected again in the next session and let's learn together again. Thank you. Have a great day. Goodbye.